It turns out that Uranus and Neptune are almost identical in color, except that we know that, of course, Uranus is tilted and it has rings. And the image of the Uranus and Neptune has been taken by Voyager spacecraft by NASA. For decades, Neptune was thought to be rich blue and Uranus was thought to be pale green. Patrick Gerard Joseph Irwin, in many images of the two outer gas giants of the solar system, Neptune typically looks rich blue while Uranus comes across as pale green. But now a new study published in monthly notices of the Royal Astronomical Society has revealed that these two ice giants are actually very similar shades of greenish blue. The study follows our previous work, he said, in 2022, that analyzed the spectral light broken down by wavelength of light reflected off Uranus and Neptune from several sources, including the Space Telescope imaging spectrograph on the Hubble Space Telescope. These were recorded in 2002 Uranus and 2003 Neptune. He said, we found that the colors of Uranus and Neptune were actually remarkably similar, with Neptune appearing only slightly bluer. The difference in color was attributed to the difference in opacity of the layer of haze and methane ice. Ultimately, Neptune has a thinner layer of haze, allowing more sunlight to reach deeper in the atmosphere. At such depth, it can be absorbed by methane gas, which soaks up red light, making the planet appear ever so slightly more blue. Now, the reconstruction of the colors. He said, our reconstructed colors of Uranus and Neptune look very different from previous images, which come from the Voyager 2 spacecraft's encounters with these planets in 1986 and 1989, respectively. So did the colors of Uranus and Neptune change between the late 1980s and 2000s? Or do we need to consider more carefully how observations of planets are converted to the true color that would be observed by an average human observer? The answer, it turns out, is a bit of both. Color images of planets are highly processed. The red, green, and blue components are usually recorded separately by spacecraft. They are then sent back to Earth as black and white images, where they can be combined in color. However, such images may not reveal the true color the human eye would see. Even light recorded in channels beyond the visible range, such as in ultraviolet, become red, green, or blue when displayed. There are several steps involved in this process, and depending on the choices made, a planetary image can have a wide range of appearances. To determine the truest color of the Uranus and Neptune up to the present day, we combined our Hubble data with more recent observations at the Very Large Telescope in Chile. Both of these instruments record images where each individual pixel is a complete continuous spectrum covering all colors that can be seen with a human eye, making them more accurate than spacecraft when it comes to color. And this allows us to determine unambiguously the actual color that the human eye would perceive for Uranus and Neptune. We could then reprocess observations made by imaging cameras on Voyager 2 and Hubble, taking this into account. When the reprocessed Voyager 2 observations of Uranus and Neptune are compared with some of the early release images, it's clear that the early Uranus images correspond fairly well with what we now believe its color to be. The early Neptune images, however, are much darker blue than their true color. The difference was actually known at the time the Voyager imaging team and the captions released with the images explained this fact. However, since the purpose of these images was to communicate the exciting new discoveries of the mission, it was quite sensibly judged that an enhanced version of the images that accentuated the discovery was preferably over a true color version where the features appear washed out. However, the differences in processing became forgotten over time, and so now most people, including plenary researchers, just accept the Neptune is much bluer than Uranus, which is not actually the case. And also they found out that Uranus changes color. As we know, Uranus has rings, as we said. Uranus changes color comparing the true color of Uranus in 1986 with more recent observations, it became clear that Uranus in 1986 was actually slightly greener than it was in the early 2000s. We tried to determine why this was the case, but turning to observations made between 1950 and 2016 at the Lowell Observatory in Arizona. These observations contain the overall brightness of Uranus and Neptune almost annually at two wavelengths, green and blue. This revealed that Uranus does change color, becoming greener at the solstices when the sun's path in the sky is farthest north or south from the planet's equator, that it is at the equinoxes when the sun's path crosses the planet's equator. Part of the reason for the color change is that Uranus spins almost on its side during its 84-year orbit around the sun. And this means that during the planet's solstices, either its north or south pole points almost directly towards the sun and Earth. Hence, polar latitudes dominate the overall reflectivity. This led us to develop a model which compared the spectra of Uranus's polar regions to its equatorial regions. We found that polar regions are more reflective at green and red wavelengths than blue wavelengths, partly because methane is half as abundant near the poles as the equator. However, this did not fully explain the color change. To match the Lowell Observatory data, we found that we also need to add a hood of icy haze over the summer. This modified model then substantially reproduced the Lowell observations and thus explains how the overall color of Uranus changes during its orbit about the sun. So the next time you see an old image of the two gas giants, keep in mind you're probably not seeing their true color. This is by Patrick Gerard Joseph Irwin, Professor of Planetary Physics, University of Oxford. It's from the conversation here, Creative Commons, on Unexplained Mysteries. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.